Hey everybody, today I will be doing another video and today we'll be doing something different. It is related to mathematics. It is mathematics, but it is a mathematics for basically mathematics for computers. I think that the binary numbering system is important to learn because now every single device that we use, a digital device, I would say, requires it operate. If it's digital, it operate in binary, and what it means is binary is either has millions of millions, well, let's say, okay, a computer, for example, or a system like this, like a phone like this, has millions and millions of switches inside the microchip, inside a microcontroller. It's a microcontroller that operates this phone inside of it, and it has so many switches that can be turned on and off too many times per second, we'll say. And those switches are considered digitally, which is on or off. It's either sent a signal saying on or off, or yes or no. In other words, on or off, on is 1 and off is 0, right? And that's how these devices work. Okay, so basically what I will do is kind of give a brief introduction to binary, right? Binary numbers, and and also introduction to base 10. So how humans understand the numbers, the countings, the numbering systems, right? And how the machine and why the machine, like a computer, for example, or digital devices, understand binary system, right? So usually, and this is important because when we write programs, for example, we program a device, and eventually probably I will do some basic programming and some microcontrollers like Arduino or Raspberry Pi. But right now I just want to teach the basics of binary system, how they work, how the binary system works, and how it's used in the digital world that we live in, right? So that is the main thing. That is the main purpose of this video, to teach the basic of binary, right? So so binary, right? Binary counting system. Binary counting system, right? BI mean 2, binary. And that's what we said, binary. Bi mean 2, so that means that this system is also called base 2 system, right? Base 2. when we count humans, right? We count in base 10, right? Computers don't understand base 10. They understand only base 2, zeros and 1. So we have to, in this, probably eventually I will do some conversion, how you can go back and forth from binary to decimal and from decimal to binary. But for right now in this video, I will just do the introduction of binary, introduction to binary numbers, right? So, so let's do this, because I need to erase this, because I need this this room here, right? So we say that we count in the base 10 number system, right? So we usually start from 0. So we do 0. We add 0 plus 1 is 1. Plus 2. I'm sorry. 1 plus 1 is 2. And then plus 1 is 3. And then plus 1 is 4. And then plus 1 is 5. And 6. 7. 8. We do 8. And we do 9. See? Now, if I just start from 0, right? How many places do I have? I have a 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Huh? Okay, so why did I end up on 9, which is in the 10th place? Well, because we start from 0. From 0 to 9 is basically the 10th place, right? If I add 1 to this, what is going to happen, right? So if I add 1 to 9 is 10, right? But I write 0 and carry the 1. So now it seems like I am starting at base 10 again. See? Now I'm starting. I am starting again in base 10 and go and go to the next 10th, right? So now we say, now that makes sense, because humans, we count in base 10, but the computer don't understand this. Computers don't understand this type of language. They understand machine language, right? Or binary numbers. Now, how we represent some switches, for example, on or off, right? Okay, so what we will do here, we will create a table. We will create a table. And let me just put a column here to kind of separate the decimal. This is decimal, right? And hopefully I can do this table you're organized, right? So let's say that we do 4 switches. Let's say that we do 4 switches, right? And those switches are represented by something like that, right? Okay, 4 switches, right? And I want to represent the 4 switches on or off. Okay? So the first, in binary, I will put, if all of them are off, I will say 0, 0, 0, 0, right? All of them, all the switches are off now, right? Okay, so if I do the same thing that I add here, 0 plus 1 is 1, 1 plus 1 is 2, and so forth and so forth. I will create a table in binary. Okay, so let's see if I can do that. Okay, if I add 1 to this 0, I know 0, 0, 0, right? All the zeros. That means that the system is totally off now. It's equal to 0. Everything is equal to 0, so the system is not running, right? Okay, so let's add 1, right? So 1, 0, 0, 0. Now, in this position, this is 1, and the rest of the switches are off, but switch number 4, you can call it number 4, is on, right? Now, let's add a 1 to this one right here and see what we get. When we add decimal, we usually do 10, or you do 5, right? Let's say, for example, 5, and then you do plus 5. 5 plus 5 is, you know if 5 plus 5 is 10, so you write 0, carry 1, and put a 1 in there, right? In binary, we don't do that. In binary, we don't do that. In binary, what we do is 1 plus 1 equals 0, right? In binary, 1 plus 1, we write 0. We don't say 1 plus 1 is 2 in binary. No. We say 1 plus 1 is 0, and then the carry, we put it like that. That will be 2 in binary. Right? So, this is what we'll do, right? Here I write 1, I add 1 to it, 1, right? So I put 0, carry 1. Now, 1, 0, 0, right? Now, add 1 to it to get the 3. This is number 2. Now let's get number 3, right? So here I will say 1, right? 0 plus 1 is 1. Carry nothing, right? Bring the 1 down is 1, 0, 0. Right? Now, here's when it gets kind of tricky again, because I have to add another 1 to here to get 4. Right? Now, add 1 to this one is 0. Carry 1. 1 plus 1 is 0 again. Carry 1. And then carry 1 here, right? And then bring it down is 1 and 0. See that? So now we're seeing okay. So now let's do this one. Okay. So add 1 to this is 1, right? 0 plus 1 is 1. Bring the 0 down, right? Bring the 1 down. And that is 5. Let's do this again. 1 plus 1 is 0. Carry 1. Bring the 1 down is 1. And then bring this down is 1 and 0. Okay, that's number 6. Let's do number 7. Now, 0 plus 1 is 1. And then carry nothing. Bring the 1 down. Bring this down. And here you go. Now, look at how many zeros I got. 1, 2, 3, 4, 5, 6, 7, 8. Up to number 7, I got 8 zeros. And we will see eventually why this makes sense. Right? Okay, so look, so let's add another one here, right? 1 plus 1, okay, number 7, I'm doing number 7 now, I'm going to get 8. 1 plus 1 is 0, carry 1. 1 plus 1 is 0 again, carry 1. 1 plus 1 is 0 again, carry 1. And 0 plus 1 is 1, and carry nothing, and that is here. So, I am at 8 now. Okay? Now, I am at number 8. Now, let's do number 9 in decimal. Let's do the representation in binary. Right? Add 1 to it is 1. Bring the 0 down. 0, 0, 1. That would be number 9. That would be number 9. Okay, so let's do number 10. Okay, let's do number 10 and see what we get. Right. So number 10, we add 1 to it is 0. Carry 1. 1 plus 0 is 0 plus 1, I'm sorry, is 1. Bring the 1 down. Bring the 0 down. And bring the 1. 10 is 1, 0, 1, 0. That's interesting, isn't it? Okay. 1, 0, 1, 0 is 10. Let's do number 11. Okay, so add 1 here to 0, that's 1. Right? Carry 0, right? Nothing, carry nothing, right? So it's 1, right? Bring this 1 down, it's 1. And bring this 0, right? The 0 down, right? And this is 1, right? So 1, 0, 1, 1 represent 11. Let's do number 12. Here I add 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0 again. Carry 1. 1 plus 0 plus 1 is 0. 0 plus 1 is 1, right? And bring this 1 down, right? So, as you can see here, that I am at number 12. What about number 13? What about number 13? Okay, let's do number 13. And let's do 0 plus 1 is 1. Okay? And then bring the 0 down. And then bring this down. And this down. Right? 13 is 1, 1, 0, 1. Let's do number 14. Okay, so number 14, I got 1. 1 plus 1, right? Again, 1 plus 1 is not 2. Again, 1 plus 1 is 0. So, you know, what I'm trying to say is 1 plus 1 is not 2. And what I'm trying to say is 1 plus 1 that is not equal to, right? That's what I'm trying to say, right? So in binary, we say that 1 plus 1 is equal to 0, carry 1, right? So 1 plus 1, 0, carry 1. 0 plus 1 is 1. Alright? Let me erase this one so it don't create confusion. So now we don't have no more carry, so bring that one, and bring that one, right? So that is number 14. 1, 1, 0, I'm sorry, 1, 1, 1, 0, right? Let's do number 15. And that is the last one we will do, right? Okay, so here, to get number 15, I just add 1, right? 0 plus 1 is 1, right? And carry nothing, right? And bring those down as 1, 1, 1. So basically, number 15 in decimal is equal to 1, 1, 1, 1 in binary. Interesting. Okay, so now let's count the places. How many places we have? If we start from 0, right? If we start from 0, we don't have 15 places. Actually, we have 16 places, right? So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay? So we go to 15. We actually go to the 16th places in decimal, right? Now, why? Because we start from 0. Okay. So, now the question is, the how these binary numbers, right? For example, from zero to 9, right? It's easy. I mean, it's not easy, but it's more doable, right? Right? So it's more doable, right? Now from here, we usually represent these numbers by letters. That is A. That is B. That is C. That is D. Actually, you know what? Let me just... Okay, so let's just write it like this without the arrow. Okay, so that's A. Maybe like that. That is B. That is C. That is D. That is D. That is D. That is E. And that is F. Right? After the 10, we represent these numbers by these letters. Right? So that's how we represent the binary numbers from 10 to 15. From 10 to 15, we represent it in this form. And so basically, this is how you derive this table. It is a good way to learn how to represent this table this way, because a lot of teachers just tell you to memorize it, and I don't think that is a good idea. I mean, I think just adding the binary numbers to get this table really help in the learning process of the binary number system. All right, so that's how we create this table. And again, not necessarily you have to do it this way, but I think this is helpful. And but again, this is binary. This is binary. All right. So this is binary, and this is decimal. And in the next video, I will probably continue a little bit how to work on in conversion and do decimal conversion to binary or vice versa. But again, this is the basic in how to go from decimals counting system to the binary. Again, this is how a human understand numbering system, right? This is how we understand, and this is how a computer understand the numbering systems. If we see here, there is some type of pattern here. Look, here I got 0. I got a 1, I got I got a 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, all across. Here I got a 4 zeros. 1, 2, 3, 4 zeros. Up to there. And here I got an 8 zero. 1, 2, 3, 4, 5, 6, 7, and 8. And I got an 8 ones. Right? And I got 4 ones. And I got another 4 zeros. So this is a pattern, how this table was created. Right? So I hope you learned something out of this video, and I will probably do more videos on how to convert these numbers vice versa from binary to decimal and from decimal to binary. I hope this helped. Anybody who is learning some basic binary counting system, and eventually probably I will do some basic programming in the Arduino and maybe do some switches so we can actually represent this table on actually programming some type of LEDs light, so we can see how we can actually develop some type of 4 LEDs so they can light in different times to represent this table. Right? Thank you for watching. Thank you.